Hey everybody. So in this video, we are talking about radians. Now, you may not have heard about radians. Maybe you have, maybe you haven't. Maybe this is your very first time hearing about them. But I know that you all have worked with angles before. So you know that I can draw an angle anywhere in a circle, right? So here I have whatever the value of this angle is. Well, now we're going to introduce a vocabulary word called a radian. And a radian also helps us measure angles. But you see right here, you have the measure of the angle right here. When we use angles and degrees, think about how wide this had to turn to create that angle. When I talk about a radian, the radian is almost the distance this had to travel to get here. Okay? So let's think about why we would use the word radian. Okay? So here I have this circle with a radius of 3, and I want to know how many of these radii is it going to take to go all the way around the circle. So if you want to, you can pause the video. You can think for a minute. Here's the length. Here's the circle. About how many do you think it's going to take to go all the way around the circle? Let's find out. Now, I know I paused it right in the middle, but I want you to see the radian is using the length of the radius to move around the circle. So it took 1, 2, 3, 4, 5, 6 radii, and then we had this length left over, 0.85. So the length of that divided by the overall length of my radius gave me a distance of 0.28, right? So 0.28 of the radius is what it would take to fill in this small little bit. So if I take the 6 initially and then add the 0.28, it would take 6.28 radii to go all the way around this circle. Okay? Now, what if I made the circle larger? So let's take this and let's make it 5. Now, do you still think it will take the same amount of radii to go around the circle? Let's find out. All right. And it turns out that it did. There are 1, 2, 3, 4, 5, 6 radii. I had this length left over, right? That was a distance of 1.42. So how many radii would that be? Well, 1.42 divided by 5 gives me 0.28. So it's still going to take 6.28 radii to go all the way around this circle. Does that number seem very familiar to you? 6.28. What does that sound like? What number are you thinking of? What about 2 pi? Because pi is 3.14, and if I double that, I get 6.28. So how about that? 2 pi r, what does that tell you? 2 pi r, that's a formula we learned a long time ago. What is that? That is the formula for the circumference. If you took the radius of your circumference and you multiplied it by 6.28 or 2 pi, that's going to tell you the distance around the circle, right? So radians are used. They are, what will we call them? Segments of the radius that we use to measure the distance around the circle. So that's what a radius is. Now, we have very specific types of radians, or what people would call as special radians. So here we have a circle, and we're going to count around this circle using pi fourth radians. And I know you're like, what? Why are we doing this? You'll see in a moment. But let's go ahead and do that. So we are going to start here, and we'll say this. Now, if I start at the beginning right here, that's 0 radians. So I haven't traveled anywhere right here. This would be pi over 4, or 1/4 pi radians. This I could say is 2/4 pi radians. And we know 2 over 4, that simplifies. So that's just really going to be 1/2. So this is pi half radians. Here, if this is 2 over 4, the next one should be 3 pi over 4. And then here, this should be 4 over 4. So I have 4 over 4 pi radians. Well, 4 over 4 is just 1, so this is pi radians. If this is 4 over 4, this should be 5 over 4. Here, this would be 6 over 4. 6 over 4 can reduce to 3/2. This would be 7 pi over 4. And then if I go up one more, that would be 8 over 4, or 2 pi radians. So you'll notice from the animation that we just watched, you're always going to have 2 pi times whatever the radius is to get all the way around the circle, right? And that's how you learn the circumference formula back in middle school. Circumference is 2 pi r. It's 2 pi times the radius, right? Because whatever the length of the radius is, it's always going to be 6.28 of those radii to get all the way around the circle. Now, there is another special radian, and that is when you count by a sixth. So if I start here, that's 0 radians. Let's make that a little bit thicker. Sorry about that. All right, so here, this would be 1 over 6, or I could just say pi over 6. Here, this would be 2 pi over 6, but 2 over 6 is 1/3, so this is pi thirds. This would be 3 over 6. 3 over 6 is 1/2, so this is pi halves. Notice how that's the exact same. I got pi halves here and pi halves here, no matter how I count it. So pi half radians is always 1/4 of a circle. Now I have 4 over 6, or this is 2 pi thirds. Then I have 5 pi over 6. Here is 6 over 6, or I could just say pi. So see again, pi and pi, it doesn't matter how I count. Pi radians is 1/2 of a circle. Here, this would be 7 pi over 6. This would be 8 pi over 6. That can reduce to be 4 pi over 3. This would be 9 over 6, but that is 3 pi halves. Now, notice I get the same number again. So 3 halves pi times whatever the radius is going to give you 3/4 of a circle. Here, this would be 10 pi over 6. That's going to reduce to be 5 pi thirds. And then here, I would have 11 pi over 6. And then 12 pi over 6, or 2 pi. So again, doesn't matter how I count, 2 pi times the radius is always going to take you all the way around the circle. So these are very special types of radians. You'll see why later when we start talking about the unit circle. But I just wanted you to see how we're using radians to count around a circle. Okay? Now what we're going to do is we are going to try converting from degrees to radians. So you are used to working with degrees, 150 degrees, 240 degrees, 124 degrees. Okay? Now what we want to do is we want to express this degree as a radian. Now, if I look on my image here, 150 degrees is 5 pi over 6 radians. But how are they getting that? How do we just know that it's 5 pi over 6? Well, we can use what's called a conversion factor. In order to go from a degree to a radian, we are going to multiply by pi over 180. So here I'm going to say this is pi over 180. So this is going to give me 150 pi, and that's going to be over 180. Now all I'm going to do is simplify this. Well, the zeros can go away, and I have 15 over 18. I can reduce 15 and 18. I can reduce both of these by the number 3. So 3 will go into 15 5 times, 5 pi. And it'll go into the number 18 6 times, 5 pi over 6. So that's how they're converting from 150 to 5 pi over 6. They're multiplying by pi over 180. So now let's try 240. So here, same thing. We have a degree. We want a radian. Well, I can look here and see that my radian is going to be 4 pi thirds. Okay? So how are they getting the 4 pi thirds? They should be multiplying by pi over 180. So here I have 240 pi over 180. Same thing as the last one. The zeros can cancel. Now I have 24 over 18. And 24 and 18 can both be simplified by 6. So 24 divided by 6 is 4. So that's 4 pi. 18 divided by 6 is 3. 4 pi thirds. That's where this is coming from. Now, what if I did a degree, that's not on the unit circle, like 124? How many radians is that? Well, I can tell you. You just multiply by pi over 180. So here I'm going to have 124 pi, and I'm going to put that over 180. Now, all I have to do is simplify. So I'm going to take 124 and I'm going to put that over 180, and I'm going to reduce that fraction. And that's going to give me 31 over 45 pi. Same thing with 750. Here, I'm going to take this and I'm going to multiply by pi over 180. That's going to give me the radian value. So here I have 750 pi over 180. The zeros can go away, so really I just have 75 over 18, and I want to reduce that. And both of those, let's see, that's going to give me, I think both of those can reduce by 3, so 25 over 6. So 25 pi over 6 radians. Now, as a sigh of relief, we're not going to work with a whole lot of real funky radians like that in pre-calculus. We're really going to work with radians that are specific to the unit circle, but you don't know what that is yet, and that's okay. What we're doing right now is building that foundation. We're getting you accustomed to going from degrees to radians. Okay? Now, let's do some practice problems. Here, they want us to convert the radian measure to degrees. So I have all of these radians, and I want them written as a degree now. Okay? So here I have 7 pi thirds, and now I want a degree. Well, if I want a degree to go to a radian, like what we were just doing, I multiplied by pi over 180. Well, if I want a radian to go to a degree, I'm going to multiply by 180 over pi. And you'll notice now, my pi's go away. Hey, how about that? So we know how to reduce fractions. This 3, that can kind of turn to 1. And this 60, 180 divided by 3 is 60. So now I have 7 times 60. This is 420. And then 1 times this pi right here reduced with that pi and turned to 1. 1 times 1 is 1. So here I just have 420 degrees. And that's it. I've turned a radian to a degree by multiplying by 180 over pi. So we'll do that a few more times. So here I have 8 pi over 11. And I'm going to multiply this by 180 over pi. So we already know that the pi's are going to reduce to 1. And now I have 8 times 180. That gives me 1440. This is going to be over 11. And that will not reduce. So here as a degree, well, we can make it a decimal. That probably is a little bit easier. So if I said 1440 divided by 11, that gives me 130.9 degrees. All right. And then same thing here. I have 1.87 radians. So I want it as a degree. So I'm going to multiply by 180 over pi. Now, I know some of you are thinking like, whoa, 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 where's the pi? The pi's aren't canceling. That doesn't matter. This decimal is the radian value. It doesn't matter what the number is, whether it's a decimal or a fraction. In order to go from a radian to a degree, you must multiply by 180 over pi. So here, I'm going to use my calculator, and that's what I'm going to do. I'm going to say 1.87, and I'm going to multiply that by 180. That's going to give me 336.6. And then what I'll do is I'll keep that over pi. So I'm taking this number and I'm dividing it by pi. And that's going to give me 107.1. Now, for the purpose of this video, I want you to try these. Do not let the negative fool you. I'll actually do one of the negatives here, and then I'll let you try the other two by yourself. So if I have negative pi over 5, the negative does not bother us. We have worked with positive and negative numbers for most of our high school experience. We have a radian. We want a degree, so we have to multiply by 180 over pi. So here we're going to say 180 over pi. And this is going to give us negative 36 degrees. Okay? Now, I want you to try the other two questions here. And then you can pause the video and try those, and then you can unpause, and I'll have my answers posted. All right, here are the answers you should have gotten. And that's going to wrap it up for this video. What is the introduction to radians, what is a radian, and then how to convert between degrees and radians. If you have any questions, please leave them in the comments, and we'll see you all in the next video.